Ladies and gentlemen, welcome to our first course about quadratic equations. We shall see this course two important things about what is a quadratic equation. The first of all, we shall define what is quadratic equations, and second, we shall state a property that we can use to solve any quadratic equations. So, what is a quadratic equation? Let's A, B, and C be three real numbers, such as A is different to 0. Why? Because if A is not different to 0, or it's equal to 0, otherwise the equation will be just a linear first order equation. So quadratic equations, it's any equation that can be written as a x squared plus bx plus c equal to 0, which a, the number is the real number e, it's different from 0, because the case where a is equal to 0, it's not very important, because just a first order linear equation that can be solved easily without any problem. And now after definition, we shall state the proposition that can be used to solve any quadratic equations. The proposition states that let a x squared plus b x plus c plus c equal to 0 be a quadratic equation such as a is different from 0. Then to solve that equation or that quadratic equation, we calculate the discriminants delta equal to b squared minus 4 times e times c. And after that, we have three separate cases, which is if delta is strictly positive, otherwise it's strictly greater than 0, then the above equation have exactly two different solutions. The first solution, or the expression of this first solution, is minus b minus the square root of delta over all over 2a. And the second solution, it is x equal to minus b plus the square root of delta over 2a. The second case, where delta it's exactly equal to 0, in this case the above quadratic equation have just a unique solution, which is minus b over 2a. In that case, we remark that if delta is equal to 0, and we substitute the value of delta in the above expressions of the solutions, the two solutions, we obtain exactly the expression of the one solution, case 2, which is minus b over 2a. If still the last case, if delta is strictly less than 0, otherwise it is strictly negative, then the above equation doesn't have any solution and the real numbers. So now we shall give some exercises to practice a little bit about how to solve a quadratic equation. So examples, we state this exercises as examples because we shall give the solution, or we will give the solution after. Let x be the known real number. Solve the following quadratic equations. The first quadratic equations, which is x squared minus 4 equal to 0. This equation is very easy to solve. We not really need to use the proposition. Just if we remark that the expression x squared minus 4, it's the identity, the third remarkable identity. So we can factorize the x squared minus, or we can write x squared minus 4 in the form of x minus 2 times x plus 2. In this case, we shall have, or we will have two different solution, which is 2 and minus 2. We don't need to use the property above or to calculate the discriminant delta. And the second exercise, we remark that 7x squared, it's a positive number, and 3 is strictly positive. In this case, the sum of the 7x squared plus 3 is strictly greater than 0, which means that the equation 7x squared plus 3 equal to 0 is not possible, because we prove that in this case that 7x squared plus 3 it's strictly greater than 0, which means it can't equal to 0. It's impossible. For the third example, if we want to solve these equations, it's very easy. We remark that we can factorize by x. In this case, the expression 3x squared minus 2x is equal to 2x times 3x minus 2, which in his turn equal to 0, which means that either x equal to 0 or 3x minus 2 equal to 0. In this case, we obtain two different solutions, which is 0, and the second solution is 2 over 3. Let's take the fourth example, or the fourth exercise. Let's solve the quadratic equation 4x squared minus 4x plus 1 equal to 0. In this case, we remark that the expression 4x squared minus 4x plus 1 it's in the form of the second remarkable identity, which is a minus b squared is equal to a square minus 2a plus minus 2ab plus b square. In this case, a it's exactly 2x and b it's simply 1. It's equal 1. In this case, the expression 4x squared minus 4x plus 1, it's equal to 2x minus 1 square minus 1 the square, which is equal to 0, which means that 2x minus 1 is equal to 0, which means in his turn that x equal to 1 over 2. It's the solution of the quadratic equation 4x squared minus 4x plus 1. For the 5 and 6 examples, I let you to solve these equations by the use of the property, which means that you have to use or calculate the discriminant delta and apply in which case the first or the second or the third case, and I let you practice these exercises.